Hey guys, Mr. Riz here to help you out on the 5.4, 5.6 optional review worksheet. So remember, this is just a version of the test that I changed the numbers on. So these problems that you guys will see on your test are going to be very, very similar to what you guys actually do on your test. Okay, so the first part is you guys are given two equations. You have an f of x and a g of x, and you're going to do all four arithmetics with it. So we're going to add them, subtract them, multiply them, and divide them. Okay, so first off, if we were going to add the two polynomials, pretty straightforward. What we want to do is take f of x, which is our 3x squared minus 7x minus 6, and we'd add the 3x minus 2. You know, probably should put these in parentheses, but addition, it really doesn't matter. We're just combining like terms. So we have 3x squared. We'd add the negative 7x with the positive 3x. Negative 7 plus 3 is negative 4, so we got negative 4x. And we'd add the negative 6 plus the negative 2, that'd be a negative 8. And so there's addition. Now subtraction, it kind of matters what order you go in. So we have 3x squared minus 7x minus 6, and we are going to subtract the whole expression, 3x minus 2. So we still have our 3x squared, because it doesn't combine with anything on the right. Then just be careful with the x's. We have negative 7x minus 3x. That'd be negative 10x. And then negative 6 minus negative 2 is like negative 6 plus 2. That is negative 4. All right, so there is subtraction. All right, next, multiplication. We're going to take 3x squared minus 7x minus 6 and times it by the whole thing, 3x minus 2. So we're going to have to distribute the terms to 3x minus 2. So 3x squared times 3x, that'd be 9x cubed. 3x squared times negative 2 would be negative 6x squared. Then moving on with the negative 7x. Negative 7x times 3x is a negative 21x squared. Negative 7x times negative 2 is a positive 14x. And now we got to move on with the negative 6. Negative 6 times 3x would be a negative 18x. And then negative 6 times negative 2 would be a positive 12. We're going to look for like terms. 9x cubed is the only one there. We can combine these two middle ones here. Negative 6 and negative 21 is negative 27x squared. Then these two middle here. 14x and negative 18 is a negative 4x. And then plus 12. All right, lastly, f divided by g of x. It's just strictly f 3x squared minus 7x minus 6 divided by 3x minus 2. We might want to go through and actually see, and you can probably get some bonus points here, is if you can simplify this. So off to the side here, can we factor that 3x squared, factor the top term? Well, two numbers multiply together to give us negative 18, add together to get negative 7. That would be a, let's see, that'd be a negative 9 and a positive 2. So we would have x minus 9, x plus 2, but we get divided both by 3. And so we would have a, if we factor this, this would be an x minus 3, 9 divided by 3. And this one here, 2 does not divide by 3, so we slide that over, a 3x plus 2. Oh, geez. If that was a 3x minus 2, we could cancel them out and simplify. But it doesn't cancel out, so really, this thing that we wrote up at the beginning is the complete answer. If it does factor out and you actually write it the correct way, showing work, I will give you bonus. Okay, moving on to the next part here. All right, some story problems. All right, demand for a company's cost at X predicted by the function. Okay, so the demand is this equation here, 500 minus 2X. The price in dollars that a company can charge for a product is this. Use the revenue, which price times demand, to find the revenue. Okay, so all we need to do is to multiply these two functions together. That's kind of nice. Actually, very similar to the review problem that we did, except for this time, I give you the formula here. So the price is X plus 5. The demand is 500 minus 2X. We're going to multiply these two things together. So it's like problem 3. X times 500 is 500X minus x times 2x is negative 2x squared. Also got to distribute the 5. 5 times 500 is 2500. And then minus 5 times 2x is 10x. Now, if we want to put this in descending terms, we probably should do that. We'll start out with a negative 2x squared. And then 500 and the negative 10 becomes a positive 490x. And then we have our plus 2500. All right, cool. All right, let's keep this going. Next, we got two equations here. We got h and k, and we want to find the value of h of k of 3. So that means we're going to plug 3 into k, get an answer, plug that answer into h. So let's first plug 3 into k. So 2 times 3 plus 7. All right, that's 6 plus 7. 6 plus 7 is 13. So that's 13 is not the answer, but it's halfway there. 13 is what we're going to plug into h. So what's the square root of 13 plus 3? Or what's the square root of 16? And that answer is 4. It's not too bad there. All right. All right, next. Move on to problem 7 here. All right. We got f of x is 3x squared plus 2, and g of x is radical x minus 4. What is the rule for the composition of f of g? So that means we're going to take g, because remember f of g is f of g of x. We're going to take this equation and plug it into that one there, which isn't too bad. So we're going to take 3 times radical x minus 4 squared by, sorry, talking to my wife. All right, so what we actually have to do here is, usually we write this out twice, but since we have a radical, actually makes our job super easy. We just distribute the square, and the square root cancel each other out. So this becomes 3 times x minus 4, just a regular x minus 4 plus 2. So distribute the 3, we got 3x minus 12 plus 2, and the minus 12 plus 2 makes it a minus 10. So 3x minus 10. All right, if you guys could pause for 1 second, I need to double check one thing in my house. All right, let's keep this going here. Let's clear this off, move on to the next problems. Okay, so in section 5.6, we're going to talk about inverse functions. All right, so first off, let's look at this inverse function here. We got complete this function here to do. All we need to do to find the inverse is replace all the x's with y's and all the y's with x. So negative 2, 5 becomes 5, negative 2. All right, negative 1, 3 becomes 3, negative 1, 0, 1 becomes 1, 0. Next, we got negative 1, 1, negative 3, 2, and then negative 5, 3. And the relation is it is or is not a function. And to be a function, all right, the inverse relation here, we'd have to make sure that there are no x's that go to this or to 2 different y's. So if we look at this here, 5 goes to, we don't have 5, doesn't repeat, 3 doesn't repeat, none of these x's repeat. So the relation is a function. All right, if we would have multiple, so like say we had another negative 5 here, this was a negative 5, and then we'd have multiple negative 5s, that is not a function. Okay, let's clear this off. Let's go to the next problem here. All right. Sketch the graph of f and the inverse of f of x. So let's first sketch f here. Is 1/2 x plus 3. So that graph would start here at plus 3, and we'd go up 1 over 2, up 1 over 2, just following the slope. Up 1 over 2, up 1 over 2, up 1 over 2. We could connect the dots, get that. Now, the dots are actually really nice, because we don't even need to actually find f of x if we just use the dot. So we have this dot here that's at 0, 3. That means we would have another dot at 3, 0. This dot here that's at 2, 4, we'd have a dot at over 4, up 2. That dot that's at 4, 5, we would have another dot at 5, 4. This dot at 6, 6 would be up at 6, 6. This dot here that's at 8, 7 would be at a dot at 7, 8. And if you look here, this would be our inverse. So we'd have our f inverse, and this is our f of x. All right, now, if you wanted to do it algebraically, we could just go ahead and take the equation. Remember, that's our y. We can switch our x and y's around. So we would get x equals 1/2 of y plus 3. So we minus 3 over, and we get x minus 3 is equal to 1/2 of y. And then to get rid of the 1/2 of the y, we got to times everything by 2. And okay, x times 2 is 2x. 3 times 2 is 6. So we'd get y equals 2x minus 6, or the inverse function is 2x minus 6, which means we'd start all the way down here at -6, and we'd go up 2 over 1, up 2 over 1, and then eventually by the time we get over 3, we'd be at there. And so either way, you can find the answer. Our next problem here at the bottom says find the inverse function of radical x minus 1. So remember, what we want to do without a graph is to first, that is our y, we're going to switch our x and y's around. So make this x equals radical y minus 1. And then we need to solve for the y. So we're going to add 1 over. So x minus or x plus 1 is equal to radical y. And then to get rid of the radical, we would square both sides. Now, we can leave it like this here because we're just writing an expression for the term. We don't actually have to FOIL it up unless you really want to. So the inverse function is, and just make sure we are squaring the whole side here. So not just the x and not just the 1, but the whole expression here is equal to x plus 1, the quantity squared. Okay, keep this going. All right, next, find the inverse function. Ooh, fractions, they're so much fun here. Remember, we take our y and we're going to replace it with all the x's. So first part, the problem becomes switching around x equals y plus 2 over y minus 5. Now we want to get the y by itself. But in this problem here, since we have multiple y's, we need to get rid of the fraction part first. That's more important than getting the single y by itself. So we're going to take this x here, and we're going to multiply it by the denominator y minus 5. And when we do that, we no longer have a denominator on here. It just becomes y plus 2. We can distribute the x now and make this an x, y minus 5x equals y plus 2. So the second step now is let's take this y and move it over to this side. And let's take this 5x and move it over to that side. So everything that has a y is on the one side. So xy minus y would equal 5x plus 2. Now that we have all the y's on each side, we can actually factor out the y because both of these terms have a y in common. Xy divided by y is just x, and negative y divided by 1, or y is -1. So we can get this y by itself if we just divide by this term over here. So y by itself, or in fact, the inverse function is our 5x plus 2 divided by what we factored out, the x minus 1. There we go. And last problem for section 5.6, determine whether these are inverse functions of each other. And to determine inverse functions, all we need to do is take one and plug it into the other and see if we get x as an answer. I'm going to take this fraction problem, plug it into there. All right, so what's 2 times, not x, but half of x minus 2 plus 4? All right, so if we distribute the 2, all right, 2 times a half is 1x. And then minus 2 times 2 is 4 plus 4. And x minus 4 plus 4 is x. And so we do have x. So yes, those are inverse functions. Make sure you show your work, not just say yes or no. All right. Last thing that we need to do here is the fun stuff, solving multiple radicals. Okay, so this is probably where you want to go ahead, pause, try this on your own, and really check these out. These are going to be worth a lot of points, so we're going to take our time with this. All right, first thing we're going to do is add the radical over to the other side. So we get radical 3x plus 4 is equal to radical 2x minus 4 plus 2. All right, we need to square to get rid of this radical, meaning we need to square this side. And so we actually have to write out the radical 2x minus 4 plus 2 twice when we square it. All right, so we got our 3x plus 4 is equal to, okay, if we square this, radical 2x minus 4 times radical 2x minus 4 is a 2x minus 4. The radical goes away. Radical 2x minus 4 times 2 is 2 radical 2x minus 4. And then we have to do 2 times the other side, so we'd get another 2 radical 2x minus 4. And then 2 times 2 is 4. Okay, some interesting things happen here. Okay, when we combine the 2 radical 2x minus 4 and the other 2 radical 2x minus 4, we get 4 radical 2x minus 4. Now on this side here, we have a minus 4 and a plus 4, so they kind of cancel each other out. And so all we need to do is minus this 2x over, so this becomes an x plus 4. Okay, now what we need to do is to square both sides to get rid of the last radical. All right, so that means we are going to, I'll maybe put over here, we're going to write out x plus 4 twice because it's a polynomial. And when we square them, we should write them out twice. And when we square this, 4 squared becomes 16. And then the radical just goes away, 2x minus 4. All right, so let's distribute the x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. And then over here, when we distribute the 16, 16 times 2x is 32x. 16 times negative 4 is negative, let's see, would that be 64? Yeah. Okay, so let's now make this equal to 0. So we got minus the 32x and then add 64 over. And so let's see, we'd have x squared, 4x, and if we subtract 32, so we got 8 minus 32. That would be a negative 24x. And then we got 16 plus 64, that comes out to be 80. Okay, so we're going to try to figure out, okay, what two numbers can we multiply to get 80? Add together to get negative 24. All right, let's see. Well, both are going to be negative. 8 times 10, no. Just 80 divided by 5. Yeah, we'll have to use a calculator here. So I don't have one near me. I have my phone here. I'm watching my kid sleep in the morning here. I'm going to sleep in a little bit. Let's see. No, it's not 8 times 10. That's not big enough. So we got to do a number smaller than 8. How about 5? 80 divided by 5 is 16. No, that's 21. Got to do something smaller. 80 divided by 4 is 20. Oh, why didn't I think of that? All right, so it's x minus 4 and x minus 20. And so that means if we solve both of those, x would equal positive 4 and x would equal positive 20. Now remember, we need to plug them both back in to see which one works. And both of these are fairly nice numbers. So one might work, one might not. Both might work, both might not. We're going to find out. So let's plug in 4. So if we plug 4 back into the original problem, I'll just do it down here and I'll erase it. We got radical 3 times 4 plus 4 minus radical 2 times 4 minus 4. Does that equal 2? So let's see, that's 3 times 4 is 12. 12 plus 4 is 16. Does radical 16 minus, all right, that's 8 times, or 2 times 4 is 8. 8 minus 4 is 4. All right, does that equal 2? Does the square root of 16, which is 4, minus the square root of 4 is 2. Does that equal 2? Yes, so 4 does work. All right, we also need to check out 20. So does radical 3 times 20 plus 4 minus radical 2 times 20 minus 4 equal 2? All right, so we got radical 3 times, that's 60 plus 4. Okay, 64 minus, that'd be 40. Wait, yeah, 40 minus 4 is 36. All right, that's 8 minus 6. Oh, not equals here, equal 2. And that works. So, hey, both of them work. So there we go. Not too bad. All right, last problem here isn't too bad if you actually know kind of the big brain way to do it and you have a calculator on hand. All right, so first thing we want to do is to isolate this radical. So what we have to do is add 16 over first, so we get 2 times x plus 5 to the 3/2 power equals 16. Then we got to divide by 2 to get rid of the 2 to isolate this. We get x plus 5 to the 3/2 power is equal to 8. Now what we need to do, big brain way, is to get rid of this radical by taking it to the 2/3 power. All right, so the x plus 5 is just alone. Now 8 to the 2/3 power. Well, let's see. You'd have to plug this in a calculator. Make sure you do 8 caret, and then you put in parentheses 2 divided by 3 power. Otherwise, you have to think of it as the cube root of 8, which is 2 squared, okay, so we get 4. And all we need to do is subtract 5 now to solve. Now that we figured out that's just x plus 5 equals 4. So we subtract 5 and x would equal -1. All right, there we go, guys. So this is a review. This will actually help you guys out a lot if you do this to study and prepare for the test. You guys have a great rest of your day and good luck on the test.